Hey, so we're about to jump into learning about the laws of exponents. So you need this paper, and I got a little excited about it and made a pretty rainbow title. So you'll have this video is going to just go through the first 5 laws of exponents and the theory behind them. For why these are the rules that we have to follow for exponents. And then in the second video, we have all of these practice problems in the back, and we're going to go through some examples. So let's jump in with one of the most basic laws, but it's actually one that trips people up a lot because it doesn't seem to make a lot of sense at first. So let's pay attention to what is going to happen if we have 0 as the exponent. So the law is actually that any number with an exponent of 0, the answer is always going to be 1. So our generalization is that b, like any base raised to the exponent of 0 equals 1, which is kind of hard to wrap your mind around because what an exponent means is that's how many times you multiply the base times itself. So you would think if you multiplied something times itself 0 times, you would think that you wouldn't get anything. But I'm going to show you in a second why this is true. But it's true. If you put in your calculator 2 to the 0 is actually equal to 1. 4 to the 0 is equal to 1. You could have a million things in parentheses, and if you raise any mess to the 0, it's just going to equal 1. So let's talk about why this is true, and then we can also talk about what does it mean to have an exponent. So let's start with something that we know, which is 5 to the 3rd. We know if we write that out, it would be 5 times 5 times 5, because the exponent of 3 means we're going to multiply 5 times itself 3 times, which is 125. And if we have 5 squared, that would be equal to 5 times 5, which is 25. And if we have 5 to the 1st, that's just going to be equal to 5, 1 factor of 5. So 5 equals 5. There's some advanced math for you. 5 to the 1st equals 5 equals 5. So if we follow this pattern, we have decreasing powers of 5. 5 to the 3rd, 5 squared, 5 to the 1st. And if we look at what our numbers are doing, each one is multiplied by 5 one less time. So basically, from here, we're dividing by 5. And then 25. Every time we decrease the powers, we're dividing by 5. Just like anytime we increase the powers, we would multiply by 5 one more time. So that follows, if we follow this pattern, if we take 5 and we divide it by 5, 5 divided by 5 is 1, which is consistent with our rule that 5 to the 0 should be equal to 1. So that was kind of a lengthy explanation, but it shows us why any number, when we get to the 0 power, it's just going to equal 1 every single time. So we'll say it's true because it follows the pattern of exponents. Whoops, sorry. Had that not scooted. So there's our first law of exponents, that anything to the power of 0 equals 1. And I'm going to switch colors. And we can start to talk about the second law, which makes a lot more sense. So if you have an exponent of 1, you just have anything to the first power, it's just going to equal the base. So our generalization of any base b to the first is b. 2 to the first is 2. 5 to the first is 5. So having an exponent of 1 just means we're going to have the same number. And if we wanted to write a little explanation for this, we kind of can use the explanation that we just gave for the 0. We can see that it's just 1 power of that number. So we can say 1 power of b. We're going to use our generalization of b is just b. That one's pretty simple. Now we're going to start to see what we do when we have multiple powers with the same base being combined together. So this is called a product of powers because we are multiplying the bases together and then trying to see what needs to happen with those exponents. So when multiplying powers with the same base, that's really important, we are going to add the exponents together. So let's do this example with numbers first. If we have b squared times b to the third. If we expanded that out long ways, it would be b times b times b times b times b. Because we have 2 powers of b multiplied by 3 more powers of b, which if we just wrote that as 1 power of b, it would be b to the 5th. So we can always do this. As long as we have the same base, we can just add the exponents together and keep them on the same base that they were originally on. So the general form of this is b to the power of x times b to the power of y equals b to the power of x plus y added together. And you can kind of see how this works. As an explanation, though, we could say if you have, we're going to base it off of this right here, so we can get used to looking at an equation that's in all variables. If you have x powers of b, right? X is the number of times that we're multiplying b times itself, multiplied by y powers of b, you have a total of x plus y powers of b. So a product of powers, meaning when you multiply your bases, right? When you multiply your bases together, you're going to add your exponents. 2 more laws. A quotient of powers, if you have a fraction here and you have x, b to the x in the top, b to the y, let's take a look at what you would do with an example containing numbers. So let's say we had b to the 5th over b squared. If we expanded it out, the top would be b times b times b times b times b over b times b. And we know that since everything's multiplication here, we can cross out these factors of b's because they make 1. then we can cross out these factors of b because they make 1. So we end up with 3 powers of b in the top over just a 1 to hold the place, because when everything cancels out, it becomes a 1. So that equals b to the third. So what we really have here is subtraction going on with our actual exponents. So b to the fifth over b squared ended up being b cubed. So we're going to fill in this blank with the word subtract. We'll be subtracting our exponents. And the reason is because the matches, so pairing one factor of b with another from the top and bottom of b cancel out. And make ones. All right, one more rule here. A power raised to another power. So let's start again with an example containing numbers. Let's say that we had b squared, and usually this is shown by using an extra set of parentheses, that we're going to raise b squared to the third power. So this third power means whatever's in the parentheses, we're going to multiply it out 3 times. So we'd have b squared times b squared times b squared, which then kicks us back to this rule, where we have multiplication of our bases, and we're going to add up the total exponents to add the powers of b. So you can see this as b to the 6th. If we add 2 plus 2 plus 2, which is also the same thing as if here, instead of writing this out, whenever you raise one exponent to another exponent, you end up multiplying those powers. So b to the x raised to the y is equal to b, and then the power would be x times y multiplied together. So our explanation would be, if you have y groups of x b's, meaning y is how many groups of b to the x that you have, then we know when we count groups, then you have y multiplied by x. That's how many of those b factors that you would have. So sometimes as you're working, until you get used to these generalizations in the rules, like when do you add, when do you subtract, when do you multiply your powers, until you get used to it, I might ask you to write it out long ways to show that you know what's going on with the exponents, and then you can kind of see which operation it makes sense to perform until you get used to the rules and how to use them sort of without thinking. They'll sort of become part of your working skill set. So we're going to save these for another day. We're going to work to get these solid, and in the next video I'll be showing some examples and how you might show your work when you're using all of the rules at once.